Hi, KGI scientists. You remember in our three KGI science episodes in the mathematics category, you remember those episodes labeled as "What's wrong with 9 plus 10?" "What's wrong with the grading systems?" and the other methods of using mathematical symbols. And those three utilizes equations and expressions and the process of solving them. But in this lesson, for the mathematics category or the chemistry category, we are discussing one of my favorite terminologies and labels: significant figures. Now the process of locating and finding significant figures is pretty simple, since we have these instructions here, which I'll read in a moment. But firstly, I have to look at the following digits first and see what they indicate. So firstly, we have two decimals here, and at the bottom, we just have a whole number. So the first one is 0.0875, and the second one is 7.75630. I'll read that again, 7.5630, excuse me. And the bottom one is 82,530,000. So now that we've gone through that, I want to look at the instructions here and see and indicate what the process indicates and how I need to go about solving these significant figures and composing the amount of them. So it says here, assure the location of any leading zeros. So I want to underline that if I can do this here. Leading zeros. So I have to look at the leading zeros for these digits firstly, and indicate if the remaining digits. So I want to look at the remaining digits. So these are the remaining digits, are significant or insignificant as a result. So I'll read that again so that I have clarification. Assure the location of any leading zeros and indicate if the remaining digits are significant or insignificant as a result. So for the first one, since we already labeled this as 0.0875, I want to look at the amount. I want to highlight this amount of significant figures. The amount of significant figures for the following digits. So 0.0875. I want to look at the amount. So firstly, I want to assure the location of any leading zeros in that digit. So in this case, this digit is considerably labeled as a decimal, since we have that little dot here, which is called your decimal point. So I want to rewrite this first. I want to rewrite this 0. Where's my decimal? There it is. 0.0. Hold on, big dot is 0.087. Okay, so 0.0875. So I want to look at the amount of significant figures for the following digits, for that digit. So to start, I want to assure the location of any leading zeros and indicate if that, firstly, is insignificant or significant. So firstly, I have this 0, and I have to bounce. I have to go to the rightmost, since these digits are to the right. I want to put this area here. So it goes to the right, and I want to indicate if these two zeros, these two leading zeros here, which these are leading zeros, and which I will not. I'll just write this as LZ for that. So I'll just abbreviate that as leading zeros. So leading zeros. And I want to indicate if these two leading zeros are insignificant or significant. So in this case, we are not counting these two zeros. So for this, since we have the decimal in there, which that would indicate if it's leading or not leading. So these two are leading together. So I want to count that as insignificant, since we do not count these two leading zeros. And now I want to look at the rightmost digits, since these two I know are significant. So I need to count the amount of how much digits there contains. It contains for this decimal here. So if I want to grab another color, I'll just do that in a few moments. So 8 7, and 5. As a result, these are 3 significant figures. These have 3 significant figures. So as a result, 0.0875 for the first one. If I want to put that as a huge circle, this is not a 0 as a matter of fact. This digit here has 3 significant figures since we're not counting those leading zeros. And the 8 and the 7 and the 5 consist of the significant figures, since these 3 are significant and the leading zeros are insignificant. So I just want to label that. I'm just going to abbreviate that as rightmost digits. I'm going to label that as that rightmost digits, which these are significant figures, or I'll just do this way. Significant figures. These are the significant figures. So that's our rightmost digits, and they are insignificant. So thus we have three significant figures for the first one. Now for the second one, which I'm not going to get tricked here. Firstly, I have to rewrite the decimal here, since it's 7.5630. So we have 7. Where's my point? That's a very bad one. But I will rewrite that. I will rewrite that actually. 7 point. It still likes to play with me actually. There we go. 7.5 6 3 0. And of course, you can also call that 0, but I just like to call it O so that I have clarification. So for the second one, 7.5630, these 3, not 3, these 5 here, and I'm not going to get tricked. So firstly, I have to assure the location of any leading zeros. So if this was a leading 0, I would have to move that so that it makes a leading 0, which that would be insignificant. But for all of these here, these 5, so I'm gonna underline these, and I said I was gonna do it in a different color, but I'm just gonna do that in a few moments. So 7.5630, all of these here are significant. So in this case, this 0 here. If I want to label that, actually, I'm actually going to do that in a different colors. So I'm just going to go with this color here. This 0 here is called a trailing 0. So a TZ. So it's a trailing 0 if I want to abbreviate it that way. So it's trailing 0. So this 0 is trailing towards the rightmost digits. So the 7 here is leading, and the 5, 6, 3, and 0 are all rightmost digits. So all of these are rightmost digits, and this trailing 0 is significant since it is trailing towards, and it is compacting with those other digits. So 7.5630, all of these are significant. So we are good. So now I'm going to let you pause the video. I'm going to let you pause the video, let your professor or teacher of any sort pause the video, and see if you can decode the following digit here. So I'm just going to rewrite this here firstly before you pause it. So we have, that looks like a squished potato, as a matter of fact, a squished rock. 82,530,000. Okay. Now I'm going to let you pause the video and see if you can decode the significant figure, and make sure you read the the instructions here. I'll read it again so that you have clarification and I have clarification as well. Assure the location of any leading zeros and indicate if the remaining digits are significant or insignificant as a result. So pause the video, and when you come back, I will make sure to count the amount of significant figures for this following digit, and see if you get the same result as me as a result. Okay, so if I went to grab a different color, grab a different one, okay, or just a differentiating color, as a matter of fact. So we have 82,530,000. So if I want to look at the amount of significant figures for this digit, so I always want to start with the leftmost digit first, the starting digit, as a matter of fact. I want to start with this 8. This 8 here, I know, is significant, since it is starting with that comma. It is near that comma, and it is the leftmost digit of that near that comma. And so now I want to jump. I need to jump towards the second digit, which is 2. So it's 82. 82 together. So 82 is significant. So since that 2 is not near a decimal point of any sort. And now I want to jump towards the third digit, 5, 82 million, 5 is significant as well, since that is a remaining digit, since that is significant as well as the 3 is significant as well, so 82,530, so it's 30, I'll get to that in a moment, or in a second. 3 is significant, and careful of this, be very careful of this, this 0 here, since we're looking at this comma here, this comma indicates if it's leftmost or rightmost. So in this case, 82,530,000 is leftmost of this comma, not that comma. Since if it were that comma, that would be insignificant. So I want to look at this comma and indicate if these 5 are significant or insignificant. So in this case, 82,530,000 is significant. Is significant. I'll say that again. Significant, since those are the 5 significant figures for that. And these trailing zeros, these 3 trailing zeros, I'll label this. Trailing, there it is. Trailing zeros. These trailing zeros here, are insignificant, since they are not following that, since they're rightmost and they don't count. So 82,530,000 is significant, but we're just counting 5 as well. So sorry, I would have put that big one. 5 significant figures, so 8, 2, 5, 3, and 0 are significant, but the other leading zeros are insignificant. So as a result, what do we learn today? So we learned that for the significant figures, we have to assure the location of any leading zeros for the first. So for example, the first one, to exemplify the first one, 0.0875. So these two are leading zeros, so 0.0 are leading, so these are insignificant, and we indicated that if the remaining digits are either significant, so we're just counting the second one, 7.563, all these are significant, or insignificant. So we're talking about those leading zeros or trailing zeros for the third one. So those 3 zeros are insignificant. As a result, so to summarize, we assured the location of any leading zeros and indicated if the remaining digits are significant or insignificant as a result. So to summarize, These significant figures helped us assisted in assuring the location of any leading zeros or trailing zeros, and indicated if the remaining digits, so whole number digits, are significant or insignificant, and thus we KGI scientists have discussed significant figures as a result.